Today in Drive Labs, we're talking about creating an advanced speed assist system, or SAS, that can understand implicit, explicit, and electronic speed limit signs, as well as their relevance to different paths on the road, all by using live perception only. Here we see our live perception SAS understanding an implicit speed limit based on this entrance to motorway sign in Germany. Specifically, the system detects the sign, classifies the sign type, triangulates its 3D position, associates that 3D position with driving paths to which the sign applies, and interprets the maximum, minimum, and advisory speed limits implied by this sign based on local rules and regulations. Until this implicit information is superseded by an explicit sign, as we see here, in which case our SAS sets the speed limits to the explicit value, 60 kilometers per hour, and then increases the maximum and advisory speeds to 80 kilometers per hour based on the latest explicit speed limit sign information. And here our SAS is interpreting speed limit information from an electronic variable message sign, which contains lane-specific speed limits. Our SAS correctly understands that the speed limits shown here apply to the left and center lanes, but not the right lane. We also note that this is a particularly challenging scenario for live perception SAS because of the electronic flicker caused by the difference in refresh rates between the vehicle's camera and the sign's electronics. And here we see our SAS interpret a series of explicit speed limit signs that apply to just the highway exit lanes, and then reset to implicit speed limits when the end of speed limit sign is encountered. And here our live perception SAS is performing sign to path association on a US highway, and it correctly understands that the 25 miles per hour explicit speed limit applies to just the exit lane. Sign to path relevance information provided by this live perception system can also be fused with information from a map to further enhance robustness and increase coverage for a wide range of real-world scenarios.